please feel free to put questions in the chat at any time. There will be time for discussion at the end, and I think Andre and Elizabeth welcome some questions throughout.
Deborah or with Olivia?
And
okay. Yeah, interesting. I think.
Yeah. Sorry there. So before we get going, apologies, just doing some technical things there. I also want to welcome you. My name is Beth Payne. I'm from the BC Children's Hospital Research Institute, and I myself am joining you from the traditional territories of the Sechelt Nation. And I know our speakers are on the island, so I think it would be a great opportunity to take a moment just before we start to recognize that we do have a diverse geographical spread of attendees here that may be joining from the many diverse Indigenous lands across our province. And it's with gratitude that we are able to join together in this manner, and with great respect that we acknowledge our place as uninvited guests on these lands who are here to learn and join together. Of course, the Children's Hospital Research Institute and Women's Health Research Institute, from which we are hosted, is on the traditional and unceded territory of the Musqueam, Tsleil-Waututh, and Squamish nations. And with that, I'm going to stop sharing my screen and turn it over to our fantastic facilitators we have here joining us from the University of Victoria. Elizabeth and Andre, please take it away.
Okay, can you see the screen with the PowerPoint? Okay, perfect. So let's get started. This is actually a two-part workshop today and next Wednesday, and we're going to go through a number of different methods, and I have a simple exercise to try at the end of today, so it should be fun. Okay, so let's get going. What we're going to talk about today is a bit of an overview of human factors, what it is, why is it particularly important in healthcare. There'll be an introduction to usability and the usability evaluation, a whole range of methods. We'll also be discussing the relation between usability and system safety. Today, we'll introduce what's known as usability inspection methods, two of the main ones. And the next week's topic on usability testing and clinical simulations will just give you an advanced prelude to. Okay, so I will just move on. To introduce myself, I'm a professor and director of the School of Health Information Science at the University of Victoria. We have the School of Health Information Science. And my background is in a master's in computer science and a PhD in cognitive psychology. And I've been working in the area I'll talk about today since about 1992, actually. It's been a while. I do research and consulting in human factors, usability engineering, cognitive science, applied AI as it relates to human factors, and health informatics. So I will just pass it to Elizabeth. Do you want to introduce yourself?
Hi, my name is Elizabeth Berkey, and I'm a professor at the School of Health Information Science, and I have an interest in do research in the area of human factors and safety.
Yeah, okay, so that's who we are. So the workshop goal is to become familiar with human factors approaches in health informatics. And I think between the two workshops, we're pretty well going to go over most of the current approaches for this. Some you may be familiar with, some may be completely new. And the approaches are used both in designing and evaluating systems with the objective of making them more usable and useful. I will start with the simpler ones and then move forward. I just have a graphic here on what we're covering. Today in the red part, we'll start with the sort of more basic stuff, something known as heuristic evaluation. And we'll move that into discussing how we apply that for safety in healthcare. We'll also talk about something called the cognitive walkthrough, a classic approach and a hybrid approach that we've worked on developing. Next week, my favorite part actually is in video recording people using systems and analyzing the actual recording. So we're going to get into that next week. In between, I'm going to have you try this recording yourself at home on Zoom or some other method to show how simple that is to get the data. And then we'll talk about how to analyze it. And last but not least, next week, we'll also talk about moving the whole approach into doing simulations that are near live or live. So just some background, let me begin with saying, of course, we all know the potential of healthcare information systems, and we preach about it and we deploy them. Incredible potential to improve and streamline healthcare. Many types of systems, and we, in our work, we work with all of these and more. Of course, electronic health records, decision support, online clinical guidelines, educational systems, a category of systems known as patient clinical information systems, handheld mobile devices, we're getting into robotics. So a lot of potential. However, I had this slide from a keynote I did a few years ago, and it still holds, I think, that there's a lot of issues. And a lot of them have to do with usability and human factors. And on the top left was one report, doctors like EHRs, electronic health records, even less than they did 5 years ago. And we'll talk about that. Next week, I'll mention a study where we use questionnaires in collaboration with colleagues in Finland who sent out questionnaires to several thousand doctors about usability in Finland. Every couple, I'll check, I think it's 3 or 4 years they're doing now. And they didn't find problems with usability going down. Instead, they found that people were still having problems, and in some cases reporting more problems than several years ago. So there's a lot of issues here. The other title here is Frustrations Linger Around Electronic Records and User-Centered Design. And we'll talk about user-centered design next week. So from our perspective, we need to consider human factors broadly. As a number of health information systems fail to be adopted, and failure can be analyzed in a number of different ways. I won't get into that, whether the system doesn't work at all or partially works or is behind schedule, are all different types of failure. But many of them relate to issues around user issues. And even technically sound systems often don't get used or get rejected by users. And we know some examples of that in BC that I won't talk about, but there are a number of them. So we need to determine why and how do we develop more acceptable systems. And so our argument is there's a real need to consider human factors much more than we do. As I mentioned, the challenges of implementing systems in terms of acceptance, usability and user experience. We want systems to reduce errors, not add them. We want user satisfaction to be high. And last but not least, issues around how systems impact workflow. Today we'll look more at basic usability analysis. Next week, we'll actually look at methods we can use to evaluate and empirically assess impact on workflow. And our argument is that issues around human factors and human-computer interaction are not the only barrier to successful implementation of systems, but are probably the single most important barrier. So we've said the problem, I've laid it out: adoption issues, implementation failure, reports of systems hard to use or potentially unsafe, and last but not least, reports of systems that were put in place to automate, but that may actually have increased workload rather than decreasing it. But not to be negative, I've always looked at the positive side of things. What are solutions? I'm solution-oriented. And from my perspective, when I got into this field in the early 1990s, coming out of more software engineering, was that there's a lot of concepts from human factors engineering and usability engineering that can be used for evaluating health IP in the design process. And as you will see, we sent a number of publications. We can modify some of the methods for doing research projects. analyzing impact of technology, user adoption, many areas. So in this course, we're going to introduce more next week what I call low-cost, rapid usability engineering. And we'll have quite a number of examples in healthcare, different types of systems. So starting at the top, what is human factors and how do we define it? I edited a journal called JMIR, Journal of Medical Internet Research, a sub-journal called Human Factors. And we've taken a very broad concept of what human factors is, more than just people in engineering departments or schools, as you'll see. And the definition I like of human factors is a scientific discipline concerned with understanding the interactions bolded among humans and other elements of the system, and the profession that applies theory, principles, data, and methods to optimize human well-being and overall system performance. And the note there, system can be a technology, it can be a computer, other software, a medical device, or even a team. So we're taking a very broad perspective on human factors in the area of healthcare IP. Now I'd like to drill down to my favorite area, which is usability. And I'll talk a bit about what the difference is in the term of usability and user experience at the beginning of next week. But for today, to jump into it, I'd like to say that usability, the definition I've liked and I've operationalized in developing many different studies, is essentially its ease of use of the system, but we can define it on a number of dimensions. How is it easy to use? Can we come up with categories that we can operationalize for developing research goals or hypotheses? Well, one of the dimensions of usability is learnability. How easy or not is it to learn how to use a system like an EHR? And we'll look at studies we can design. And this can be looked at, for example, learning curves and learning and how to use Epic or Surma or other systems. And we've done studies on this. Secondly is effectiveness, another dimension we may or may not want to focus on in the study. If a system is to provide alerts or reminders, is it effective in doing it? But do the alerts or reminders come after you've given a medication? That's not very effective. Thirdly is efficiency. It may do what you want, but did it take 10 mouse clicks when it should have taken 3? Fourthly is satisfaction or user perception. And I won't focus a lot in the workshop on usability questionnaires, but I will contrast them to a number of methods that we're going to talk about that are the user's perception. Often the questionnaires will give you the perception. And last, of how satisfied or not the user is. And last but not least, this definition came from a textbook by Priest in the 1990s. They included safety. And I like this definition because safety, as we'll see today, is closely related to usability. So overall, what approaches are there for dealing with these issues? I will say usability evaluation at the detail level. Usability inspection is where we are the inspector and analyze the system. It's not observing the user, but we analyze it. And I'll go through the two main methods today. Next week, we'll talk about a methodology where we can objectively evaluate at any level of detail human-computer interaction by video recording user interaction and then analyzing it using coding schemes. That will be next week. And thirdly, we will also talk about what we've termed clinical simulations that are like usability testing, but even more realistic when we take the recording into, say, an operating room or other clinic. But those two I'll get to next week. The other thing I will touch on a little bit in this workshop is what I call usability in the labs. How we can analyze, say, hundreds of thousands of health professionals using a system remotely. And that also touches on the example I gave of giving out a usability questionnaire online to several thousand people at the same time, also usability in the labs. But we'll start with usability in detail. And just as a bit of a teaser for next week, as I said, my favorite topic is actually usability testing. And in this course workshop, I want to prove that this can be done effectively without having $1 million usability lab or having to hire PhDs in engineering. And that will be what hopefully I can prove to you by the end of this. And that's basically where we sit down in the picture there. I'm recording myself using a personal health record. The screens are being recorded on my computer. If it was a Mac, I can record it in QuickTime. I can play it back. And you can't hear me, but I'm thinking aloud what's going on with my mind. But I get to that next week. I will say the methods I'll talk about today and next week can be used throughout the system development process, including we've done projects, as I've said, well over 100. I lost counting with companies in the design process. We work with hospitals that are implementing EHRs. We've even worked, and I'll show you how the methods can be used in selection and procurement of health IP. So with that, I'll start right into the first 7 methods, kind of basic ones you may or may not have heard about. They lump into the category of usability inspection methods. Kind of comes out of software engineering, where it involves one or more evaluators or inspectors. And on my take-home little exercise to try, you will be the examiner of the interface. But we're not observing the users with us. We become trained analysts to analyze aspects of the user interface or system. And this may involve, if we want inter-rater reliability, more than one inspector, maybe 2. And the 2 main methods I will go through. Well, the first one's called, very basic, as you'll see, but very powerful, even though it sounds simple. It's called Heuristic Evaluation. And what it is, I put a quote there from the person that put this out there, Jacob Nielsen. It's the heuristic evaluations and involves having a small set of evaluators examine the user interface and judge its compliance with a recognized set of usability principles or heuristics. And there's another person, Ben Snyderman, who developed something parallel, I think actually earlier, if I'm correct, called Snyderman's 10 Golden Rules of Design. And as we'll see, the principles can be used both in designing and in evaluating. So there's 2 sides to them. So the overall approach is that you as the evaluator systematically step through an interface you're analyzing. You could do this screen by screen. If you're a web application, you might write down the URL and print the screens for reference. You basically look at the screens using this method and compare them against the list of heuristics. And I will show you Nielsen's 10 heuristics and 2 more that I added on. And remote problems in the log file and create a table or form. We can even do screenshots. This method, although it's very simple, is extremely useful if we're doing consulting work and we want to communicate to designers exactly what screen or page they have problems with and how to classify the problem. So don't be fooled by the simplicity of it. It's powerful. The approach that we use for this, that we use for cognitive walkthrough, that I even use for recording people doing things, comes again, a basic aspect of human factors engineering is called task analysis. And what is that? The idea is that in order to make any evaluation more scientific or replicatable when we're dealing with human factors and user interaction, is you need to specify what task we were doing when we did it. So if I was going through an interface and said it was well designed and someone did the same interface and said it was poorly designed, we may be looking at different parts of the system. So we like to specify for all the methods I'll talk about over 2 weeks, what the task is we were doing when we're doing it. So the task could be something like using, again, electronic health record for ordering a drug or a drug administration system or entering patient data, but we specify that. In addition, as background to specifying the task before you apply the heuristics, you also, if you do find a problem or violation of the principle of good design, and Nielsen came up with a 4-point rating scale. It's a bit subjective, but we can define what the categories are. If you did find the problem, one, it's cosmetic problem. Only fix it unless there's extra time, if there's extra time. So, okay, somebody says it's green, but they like blue and nobody can decide, but it's okay, that's cosmetic. Numeric rating 2 is a minor usability problem. Fixing of it is given low priority. 3 is a major usability problem, important to fix. These are ones I would go back with a report, and I have students and consulting, they do reports as an exercise that are consulting level. They can actually go back after applying this and show them what screen to go to. A major one should be fixed, but the interesting one at the end is level 4. Usability catastrophe. Do not release the system until you fix it. And next week, I'll give an example of a few usability catastrophes. And that could be that the system crashes. In healthcare, we've extended that to include something that provides false information that could be life critical. In one case, we found out the body mass indicator wasn't calculating properly, and we call that a usability catastrophe. Oh yeah, and Mollusk asked a very good question. For a system with many features, is there a target for the number of tasks that will capture the majority of problems? Well, next week I'm going to talk about, say with immediate saw, creating a little tree of what the functions are, and then working with whoever hired you out to look at what area you're going to focus on, like medication administration, because you can't evaluate everything, and then working with them to define where the pain points are, where they want to go and analyze. Very good question. We can't do everything, but we can prioritize what tasks. So I'll go through these simple yet powerful heuristics and show how these are used, and then how we've extended them in areas like patient safety. Well, heuristic 1 from Nielsen is very simple, called visibility of system status, that the user should always know what state the system is in at any given moment. You don't want to be wondering, did that order go through, or that medication, or did I cancel that order? I give an example. This was it was a radiation machine called the Therac, where it was unclear on the device that the oncologist was using for pressing for or the technician for radiation, and it was unclear that it had completed. So it was a famous case. They hit that 6 times, and the patient died. It was a famous safety error, but the display didn't clearly indicate when they analyzed it what it was doing. And often we might have something like an hourglass or status bar indicating that. If you're starting a system up and you don't know whether it's going and you hit the game, and then that comes up 5 times and crashes, that was a system status error. 2 is called match the system to the real world. Basically, use the natural language of the user, not jargon or system terms. If it comes up on the button and says downloads, does the user of a layperson know what that is? Maybe free trial software, but will they know what software is? You have to plug it, the labeling to the end users. This has come into play a lot more since we're now doing apps for patient use and that. And no matter how much we try on apps for patients to make the language suit them, we're often missing the mark and having to have people go through analyzing the level of the language, and does it imply that they needed medical knowledge? So clear meaning of labels as well. Heuristic number 3, user control and freedom. In the system, they should be clearly marked exits. If you have that and you know where you're at in the process, that supports undoing and redoing a transaction up to the point where you commit the transaction, like entering the med. It makes it harder to perform irreversible actions. It might say, are you sure you want to do this at the end? And then that also facilitates people in learning how to use the system if they know it's forgiving up to a point. Another very important one that comes up a lot, even when we analyze the video of user interaction. And next week, you will see that we took some of these categories and actually use them for a different purpose for analyzing video of interactions. One that comes up a lot is called consistency and standards. that operations within the system or even the page you're on need to be consistent. For example, you don't want the system to have two ways of exiting. Click on the right here and the next screen the left. You want consistency. And an example of how important this was in design of health, not health, but all systems for use by personal use, was the idea of having consistent menu items. Until the Macintosh interface, I think it was 1986, they developed specs that all Apple interfaces for the Macintosh had to follow a certain order on the menu for file, for example. New, open, save, save as. That was very powerful because before that, there were different orderings of those operations in all different applications. So you can see by doing that, and Windows even adopted that, that was consistency in the menu items. And again, with web-based applications, as an example, we don't have a fixed standard, but we'll see this. Does the interface fit with the de facto standard? Does it look like a web page? I've seen a lot of electronic health records that were initially done in Windows and then ported to the internet and the web, and they don't look right. They look like web Windows applications on the web. Heuristic number 5, error prevention. That the site or applications should be easy to use and understand when the error message comes up. And I have it one there from days long ago when I had actually Apple II. And they actually have errors that would come up like error 404. And unless at the time we actually had the printed manual, we wouldn't know what that meant. And we still see problems like this today. If you're a Unix user, you might get an error, fatal error, core bump, and not knowing what that means. Heuristic number 6 comes from psychological principles that apply recognition rather than recall. Again, this was the idea of having icons or menus so that people don't have to remember what to type in to use something. There are exceptions to this rule. If you're a super Unix user, you may want to use command line and we've memorized everything for speed. But often we want to have less demands on a person's memory, and having a button for doing something or a label is a lot easier than trying to remember what to type. Flexibility and efficiency of use, Heuristic 7. The system should be flexible, or the part of the system we're looking at, to make it so that it's optimal. You may have extra features, but you may want to layer them underneath the front end of it. But you don't want to overdo. Sometimes applications have overdo flexibility and efficiency. For example, Microsoft Word automatic formatting can sometimes get ahead of itself. Related to that is a good one. Heuristic 8, aesthetic and minimalist design. Adding a lot to a web page often doesn't make it better. Making a screen so complex with so much information can create cognitive overload. In the example of electronic health records, that can happen. So reasons, technical, bandwidth could be critical. Psychological, we'll talk about this again. The average attention span and ability to focus is short. So often the simplest interfaces do quite well. And I give an example. If some of you remember when search engines first came out, there was Yahoo, About.com, many other ones, and they were all competing. Google seemed to have won out. Why did it win out? Look at the Google screen. It's actually a perfect example of simplicity. There's a text box in the middle and a few icons you can click on to go to a deeper level and bring up other functions. Again, there could be a principle used in design for health IP, layering complexity. Another one, heuristic mind, is helping the users to recover from errors if you have them. I'll give you an example of a violation. If I go to Air Canada and I'm filling things out and I have an error, I submit it, it comes back and then says I have an error somewhere on the page. A better system actually shows you where the error is, perhaps as you're entering it. So on there I have a screen with choosing a recovery tool. If you crash the system, how you get back in. This one may seem obvious. It's called Heuristic Pen, help and documentation. there should be some form of online help and documentation. And furthermore, it should be easy to use, like clicking on how do I, why can't I, or how do I. Many applications I've looked at with Health IP can be in the middle of it, and there's no clear way to get to context-sensitive help. May seem obvious, often not there. That ends the PEM heuristics that Nielsen had, which, as I said, are very similar to Smiderman's golden rules of design. Nielsen taught them as evaluative criteria. Smiderman had them as design criteria, very similar. So the two sides of the same coin. 11 is one that I've added called thinking. Thinking is a cognitive tool that allows humans to simplify perception of their environment. We cluster things in clusters. And there was an important paper, I think it was done back by a psychologist, Miller, I think 1950s, called the magic plus or minus 2 number, that we remember things in clusters of 7 plus or minus 2. Although the caveat is, if you're an expert, the clusters may be bigger. But for example, telephone numbers were originally, before area code, 7 numbers. So I give you an example in design of an interface or in evaluating it, that a good menu system is organized so that you have menus with 7 plus or minus 2 items. A university I once worked at, York University, had a menu on the first page with 50 items. The problem is, by the time we get to the 50th, we forgot the top. So we write with trunk information. This is a screen, I have a reference to the paper, that I will have to say, electronic health record screen. I'll talk about this one more next week with usability testing. But it didn't particularly trunk things well. There were a lot of icons across the top, the side, and they didn't really follow that rule. However, this is one of my favorite screens, was from colleagues of mine at Columbia University in the 1990s, developed, I believe it might have been the first web-based EHR called WebSys. And I brought on the project working with them on the first patient-accessible access to their own records over the web. And that was only about 20 years ago. It was the very first time patients were allowed to see their own records over the web. So we wanted the interface to be very simple. We used the web-based metaphor. It looks like a web application with 3 panels. But for this purpose, I'm just pointing out that the menus all had 7 plus or minus 2 items. So it conformed to that rule. And last but not least was one I picked up from somewhere else called, use the inverted pyramid style of writing. It should make sense that most important things should be at the top. Since reading long pages on screen can be painful, we often look at the top. How do we prioritize the impact? Could go at the top. How many people affects an announcement for the whole hospital? Timeliness, is it the healthcare drug alert? And prominence are some criteria. So anyways, that gives you an idea of the most basic heuristics that were ever published and how we could use them. We'll move into more complex applications shortly. But how do we use this? Assembling the data. I said we're going to give yourself a task. And my little exercise probably will be look up a health website between now and next week, like Canadian Diabetes Association or Cancer Association. Give yourself a task, like looking up prognosis for a particular cancer, and then step through, and I'll show you applying these criteria stage by stage. We'll come up with quantitative measures of the overall number of unique usability problems that we identified, and we can compare 2 interfaces for the same task. We'll have 2 different types of graphs I'll show in a minute. But you can make yourself a simple worksheet. This one, for the EHR example, the task was accessing patient case information. I listed along the side the 12 heuristics from this lecture. You could try it from this lecture. As I step through during that task, I note conformance with the heuristics, and I note if there's any serious violations. The comment about it, That's severity from cosmetic to catastrophe. And then often, if I'm doing this as a consulting report to a company, I'll attach a screenshot where I can actually pinpoint and show them where the problem is. And often they will fix it. So this is beginning to fill out one of those forms. I marked X's in doing this task where there was evaluation on visibility. It didn't show me status of the system. It was not a bad problem. And then I have a screenshot of it. When I do consulting reports, I often compile this into a manuscript, have a screenshot, and actually circle the problem. So as you can see, we can go through and doing the task and make notes of this in the log file. If we have more than one person, we can have them both do into reliability. So what can we do? In the report, we can also have on the x-axis a graph of violations, all the 12 heuristics listed on the x-axis, and then their frequency. What are the most violations from? So in this graph, user control and freedom have most violations, and we can go back to the log, see what they were from the comments, actually go back to the screenshot. In the course I used to teach on human factors, I would have students compare two interfaces on the same task and create the graphs and compare them. So for example, I think I had them do book a ticket with Air Canada to New York from Toronto to New York and then analyze it. And then also do it with Canada 3000 and analyze it. We could compare how many problems there were. Turned out Air Canada had more problems, but Canada 3000 didn't stay in business for other reasons, but they had a very nice interface. We can even do a graph of 4 parts on the x-axis: cosmetic problem, minor, major, catastrophe, and then for the applications on that task or set of tasks, how frequent was each category. So you really don't want to see a graph that has 4 usability catastrophes like this one. So as I said, we can report the results, including screenshots. We can include recommendations on where we'll improve the system and compare products on two different products on the same task. I will talk about that point in a moment because we've actually used some of these methods in the selection and procurement process for things like virtual healthcare applications, where the organization, healthcare organization, had to choose between different products. We requested, or they requested, that they have access to at least a demo system or frame system over the web, and then went and compared them, 2 of them, on using this method. So that's the first method. And before I describe the little exercise to try, the second method is called cognitive walkthrough. Again, this is a method where we're not observing the users. We'll get to that next week. But it's another very practical method. You try to focus on pretending you're the user. It's a bit hard to do, but what level would they be at, what goals they would have, and then you make a log file of your actions, of what you click on, what comes back from the system, and potential problem. And again, we will do this in the context of specific tasks. So we assess usability for specific tasks. The analyst, again, steps through the interface, and we ask, can we anticipate user goals, what actions they will do, and potential problems? So in one of the papers, I'll mention which one, we had an example. You could write it on paper or create a log file or Excel sheet on another window. As you're stepping through a system or interface on a task, like an EXR, you specify the task, enter a problem, and the problem, this is the problem list using an EXR component. So what's our goal? Enter a new patient problem. And that example was fear of traveling into the system. The sub-goal, we have to decide on what system operation. It's going to be add new problem. That's a bit subjective on the goal and sub-goal, but what is very objective is every time we do some action, we can label it as a user action. User action is click on the button labeled add new problem. And again, we can objectively say for that action, what was the system response? In this case, a keyword search window called the med viewer appears. It's like a pick list to enter a term. Potential problem is a new user may not realize that they must enter a search term in the new window that comes up. And in that paper, I actually had a screenshot of that system. It was called Buffers Outpatient System. And a bit hard to see, but on the right-hand side, what popped up was a window called the CPMC Med Viewer. And that's what we're talking about. Then we would have to enter, in this case, you would record, entered the word travel, completions came back. So we're recording everything you're doing. Yeah, the user action, enter the term in the med viewer search box. System response, system returns control list of terms from the control vocabulary. User must scroll through the list, that's another action. And then the user selects something that fits their intention. But this system didn't allow you to have another category. You must select from the boxes of what's listed. So right off the bat, we have a potential problem. But what happens if the list doesn't contain the term the user wanted? There's no map. So again, this was very useful in refining the user interface. The results of the walkthrough, we can call this a predictive form of analysis because we're predicting things we're not observing. But we were able to come up, we can count number of actions, sub-goals, how many system responses, and how many potential user problems. I will say in doing this, you can never really know for sure that we do this in conjunction with the methods I'll talk about next week, where we actually record the users. But these are quick and dirty ways to analyze a system if you're a good analyst. Either before, I would say not in replacement of, but before doing the actual user studies. How can this information be used? As I've shown, we can use it for optimizing interface design, identifying potential user problems. As I've mentioned, we've even used it for comparing systems. How many steps does it take, efficiency, to enter a medication in two different systems? Where one may take 18, and literally we've seen some take half as many. I will end this section with one example of something a little different. If you want to be a bit fancier, we published on this. This was work by myself, Helen McMahon, Danica Poom, who I think is online, Paula Bellwood, and Elizabeth Rickey, where we said, can we not combine the value of both of those methods? So it's a combined heuristic evaluation and cognitive walkthrough. If you're interested, if you want to do the simple approach, don't do this, but we simply, this example was of an evaluation of a system called the CPRS. If you're familiar with the US Veterans Affairs, this was a gold standard system, one of the most widely used systems in the world for EHR. Millions of patients have been on it for decades. We went through analyzing why it was so successful, comparing it to another interface. But for this purpose, in this table here, was our logged file of stepping through the task for adding medication to the client profile. So you can see there's a goal column, that what we want to do, enter a potential problem. And then there's an action. Actions are noted, what we're clicking on. For example, sub-goal 2 in the middle, the goal is to add medication to the patient profile. The action is click on the meds button, etc. System responses are indicated, exactly like in the cognitive walkthrough. However, what we did was on the far left column, as we were doing that, we also indicated if there was evaluation of any of those 12 heuristics. So all we did there was we numbered them, like you'll see on the heuristic column on the far left, some numbers are there, like 1 and 8. That was evaluation of heuristic 1 and 8. So we're able to methodically step through and get the value from a cognitive walkthrough and also the heuristic evaluation. So, oh yeah, before I pass it on to Elizabeth, and we're on for an hour and a half, right? But we won't take the whole hour and a half. That's right, Candace, I believe?
Yes, that's right.
Okay, perfect. So there'll be great time for questions at the end of Elizabeth. But I will come back to this at the end. It's a simple exercise. Try at home. If you have time, if you don't, that's okay. We're not going to mark you on it. Try out the heuristic evaluation. Pick any health website or application. If you want to try it on Cerner or Epic, go ahead. But you could try a health website, Canadian Diabetes Association, run a prostate cancer site. Pick a task that a user might do. Like a lay person may want to look up what the symptoms are of a disease. And then you can do it informally or make a log file of a heuristic evaluation and see whether you can apply those principles or note where things follow or violate them. And then based on that, would you have recommendations for improving the system? Secondly, you could also try the same thing. Go through the same task on the same interface, give them do this on paper, step through and make a log file of the cognitive walkthrough and see what value that might give you. How do the results compare between the two? And how do you think you might be able to use them? So nothing very formal, but between now and next week, if you want to try it, I do have references, but everything in the slides above should allow you to try it out informally. So I think I'll pause right there before Elizabeth comes and just say, are there any questions on the methods I mentioned so far? There will be more coming. This was just one set that comes out of human factors. Obamacare made a comment, it's very efficient and effective method of evaluation. Yeah, probably referring to the combined one. Yes. And there's others. What Elizabeth now is going to show is how we can specialize that and create evidence-based heuristics about evaluating specific aspects like system safety or medication administration. Any other comments? Yeah, if we have a comment in the chat box, I think then we could unmute you, but I don't see. Oh, here's one. What about other sets of principles, Scotland and Bastard? Yes, there are other sets of principles. This is a good point. Some of them are more specific to types of applications. I'll give you an example. This one, Nielsen's classic one, had system status. Always know the system status. Well, Elizabeth and I created a set for pervasive computing. And what is pervasive computing? That's like smart home stuff that is in the environment that normally you don't want to know what's going on unless it breaks down. So our first heuristic was modified and said, keep the system status out unless there's an operation failure. There's other ones. So yes, there's other usability principles. Another one is if you were doing applications for patients to use, there's applications about criteria that they could use that are to do with do they find the site credible or not. Those are other sets of criteria that can be operationalized as heuristics. So yeah, excellent question. I think what will help is the presentation now by Elizabeth will provide an example of how we've gone further with this line of methodology to develop more specific heuristics. And as I said, this week was more about this. Next week, we'll look at how we analyze the observations of actual use. So I will now pass it over to Elizabeth.
Hi there. So I'm going to talk a little bit about some work we've been doing here at the School of Health Information Science and an extension of the work around heuristics. And I do quite a bit of research in the area of safety. So there are some, as you can see, some linkages between safety and usability. So initially, the work kind of grew out of some research that we did actually in 2005, where we identified that certain systems can actually introduce new types of errors. And as a result, we need to have some way of actually diagnosing these errors and addressing them from a systems perspective. So one of the things that we did early in that work is we decided to come up with a definition that was appealing to or understandable by varying different groups who work in the digital health area. So not only engineers, computer scientists, health informatics professionals, but also clinicians. So that way they could identify what this particular issue is and actually report on it, so we could identify ways of improving systems. So our definition around errors involving technology looked at things such as the design and development of the technology, its implementation and customization, and some of the interactions that arise from it. And these were errors that were either caught by the clinician in some cases, in other cases they weren't. And as a result, we wanted to start looking at what these particular errors did. So some of our research involved documenting different types of issues. So, for example, one issue that is quite common involving errors in user interface designs is a default auto-populates a particular field, and then there's a perception that the dose, so for example, for medication is actually an incorrect dose rather than the correct one because the auto-population fills that field with something else. We've had studies where we've done work around issues around the actual display itself, clinicians not being able to read what's present on the screen or be able to identify a particular issue because it's not visible to them in the way that the screen has been designed. We've also had studies where we've looked at things such as navigation problems, consistency problems between different parts of the user interface, and even between different modules within a system, and also things such as clinicians not being able to understand what a label means. When it was designed for by a different group of individuals, and as a result, when it went into the clinical setting, they didn't understand what the label meant. Other areas that we've also looked at are things such as how these particular issues can lead a clinician to be more screen-driven rather than driven by the actual clinical visit. It could also lead to things such as issues around diagnostic performance and errors, as well as leaving some important information that may be relevant to that particular case out when the user interface does this. So in that, we did some research where we actually looked at the relationship between usability and safety, and we did find that there is a correlation between usability issues and safety issues at the same time. This actual research ended up winning an award internationally because of the fact that this was one of the first times that usability and safety were connected. In an extension of that work, what we did is we started to look at trying to develop different types of methods that could be used before a system's implemented, after a system's implemented, and last but not least, after an event has occurred. So this is after a system's been in place for a while. So that way it turns into a quality improvement activity. So given the context of the prior research, and Andre talked a lot about this, you can see that a lot of these heuristics are fairly general. So what we wanted to do is to create evidence-based safety heuristics that would help identify potential issues in a user interface and help the teams that are essentially running these systems to make these user interfaces much more safer over time. So what we wanted to do is we wanted to do that research and sort of identify what specific user interface features and functions that are specific to healthcare in this case would be safer to have and to create that as essentially a guide going forward, so that individuals would be able to use this to support their decision making around how they might design a system or how they might actually configure a system. And it might also be used in terms of procurement, as Andre mentioned earlier. Integrating this into a procurement approach helps also to identify potential issues. So this work actually was done by one of my former students. His name is Chris Carvello, and he had an interest in this area. So we worked together as a team and with Andre, and we worked on identifying and developing these types of heuristics. So Unlike prior work, this particular work focused on actual evidence. So we looked at research that was published specifically focusing on errors. And then after that, we amassed the research and we did a panel type format where we looked at the research and then looked at how we could create heuristics that would match what the research showed as evidence. And again, very different in terms of being very specific to this particular area of work. We identified several different themes in these particular heuristics. So for example, there was usability and safety issues around workflow, content of this system's content. There were specific safeguards that were associated with higher levels of safety, as well as some features and functions that could actually influence how a system was safe or wasn't safe. So here are some examples of heuristics. So for example, you could have one that talks about function, and a heuristic would be the system allows for linkages between medication ordering, administration, and discontinuation of procedures. And this is specific to electronic health records. So thematically, what we did is we broke the heuristics down into 4 different areas. And as I mentioned earlier, and as you can see, we were able to generate quite a few different heuristics for each of the areas. So this is an example of a set of heuristics for content issues. So for example, there's a real need to clearly display the date and time of a medication if you're using an electronic health record system. Surprisingly, not all EHRs do that. There's also like another heuristic here that says display and indicate normal ranges for doses. And again, surprisingly, not all electronic health records do that. We looked at workflow issues also. As I said, we just decomposed these heuristics into 4 different thematic areas. So things like, for example, having a clear log on and log off. Looking at how flexible the screen sequences are and whether that causes issues for the clinician. We looked at functional issues, and these particular issues looked at things such as having menus that were clearly marked, that they were scrollable, and that there were linkages between things such as, for example, ordering a medication and also its discontinuation. And last but not least, we had heuristics that were looked at that followed the theme of safeguards. And in this particular case, we recommended, based on the literature, that you would have certain features that a system would have, such as an electronic health record that would, for example, check for drug-drug interactions and drug IV interactions. And not all systems do this. Overall, we created quite, 4 different areas of heuristics, and you can see that they're actually deconstructed here into their respective areas. One of the things we noted was that there's some overlap between content issues as well as safeguards, because they couldn't be actually easily extracted. So, and on that note, I'm going to pass this back to Andre, who's going to talk a little bit about your homework for next week.
Okay, so what we thought through the prior, I've gone over this slide. I'll just mention it again to be clear. To try out, it might be interesting to try out both the heuristic evaluation, the basic 12 Nielsen's heuristics. Pick an application, could be a website, could be something you're working with, doesn't have to be. Come up with a task and then try out both the heuristic evaluation and all those heuristics at the top. Oh yeah, we will have time to ask questions. We will have a good time to do that shortly. And also the cognitive walkthrough. So try that out. And just before we hit the question period, next week we're going to be talking about usability testing and clinical simulations. This is different. This week we mostly talked about you, the analyst, analyzing the interface. And no, you don't need a PhD in human factors to do this. I teach a course in this with my master's in health informatics students And within 1 month, I had them do what I call a mini project where they do like a consulting type report. And some of them after 1 or 2 tries are at the level I've seen of professionals. So, and same with the usability testing, but we'll get to that next week. It can be done in a simplified way, but scientifically. So that one is what we're going to call low-cost rapid usability engineering. On the top image there, again, that was me recording myself. I could record somebody else using a system. Everything on the screen's recorded, what I'm thinking aloud, if I'm talking to someone, and we may or may not have an external camera. I'll get into all that next week. It can be done very, very simply. In fact, now we can do it over Zoom without any equipment. On the bottom right is something I'll get into, how we can even extend the process. That was the very first time that we ever studied the doctor-patient computer interaction. People said, how can we do that? So we actually developed the method, and since then have done a number of studies and worked with companies on answering the question, how does the system affect the work activity in the real activity? So we'll do that next week, and also how to analyze what we call near-live scenarios. We'll also cover qualitative coding of how we can use coding tools and that for that video data. It has some parallel to this week because we actually put some of those categories by consistency in that, and we created video coding categories for identifying on the video when someone had a consistency problem. We'll get to that next week. The other thing before next week, like you to try recording yourself, because then you'll see that the data I'm going to talk about next week is so simple to get. Try recording yourself. If you have a Mac, I have on the next slide the instruction, QuickTime, there's a setting, you can record yourself going through an application or website, turn audio on, and then you can play it back. This is going to be our starting data for the more advanced methods. If you're using a PC, I use something called Hypercam, which used to be free. You can download it now for permanent use for $10. There's a link there to free recording software. It's software that will record what you're doing on the screen and the audio if you're using a computer. And we'll get into what you do on a mobile device later next week. But just for simplicity, you can find a way to record simply your interaction with the system on a PC or a Mac. As I said, QuickTime is built in on the Mac. So what you could do for this one is nothing really formal yet. Just go to, could be the same health website, or if you have it on your laptop, Zoom, Epic, any real system, whatever you want. Turn on the recording on your laptop and then interact with it again to carry out a task. So we're still into task analysis. The only other thing you can do with this that's kind of interesting is when you're doing it, think aloud. So what does think aloud mean? It comes from cognitive psychology, and I've done a ton of work with this. It's very simple. The idea is you verbalize what comes into your mind when you're doing it. Not thinking back on what you felt about it, but what's happening at that time. So if I'm trying to enter medication, I'm going, oh, okay, but I can't find the enter button. There it is. And oh, the room is too hot. I have to open the window. That's all part of think aloud. And that will be overlaid on the actual recording of your interaction. And next week, we'll see how that can be analyzed. Oh, one other method that's really simple is create a Zoom meeting for yourself, share the screen, and on the shared screen, you have the application you're working with. Hit the record button. So what could be simpler than that? When we got the COVID, people said, oh, we can't use your methods because we're going to have to bring video recording in. And we said, no, we can do it all over Zoom. There's times when we want to record what they're doing in the room, but this is gone. So at any rate, for next week, simply try the heuristic evaluation and cognitive walkthrough if you can. And I would say just try out recording yourself, no more than that. Oh yeah, and I have a slide here, Hypercam, you can download if you're on the PC, and there's many, many other software free. If you're on the Mac, QuickTime have it built in, last time I looked. Oh yeah, and then I have some readings, and we handed out an outline. The one to look at, maybe if we're only going to look at two, would be the first one. It's more like a manual about all of the methods. It's the Christmas and Papel 2004, Cognitive and Usability Engineering Methods. That is sort of lays out all of the stuff we're talking about. And if you're interested in a particular study, how the methods were used for a published full research program, actually, the very last paper that's listed, Papel and Kushner, Yang and Yale, was on impact of the computer-based patient record system on data collection, knowledge, organization, and reasoning. And that one I'll pick up as an example next week. But at this point, we'll open it up for questions. So I think Beth had a question about safety, and how do you want to do? Enter in the chat box, or you can turn mics on, doesn't matter.
I just changed the settings so people can unmute themselves if they have questions, or you can raise your hand, put things in the chat.
Yeah, and I'd like to just say thank you so much, Andre and Elizabeth. This was so helpful, and you provided some great resources and heuristics and forms that we can use. I know a lot of people on the call have called because they are actively looking to apply these usability principles to their work, and I encourage you all to actually participate in these activities and the quote unquote homework that we have. If you are evaluating a system for your research, I encourage you to use that system for the homework. We will be sending out the prompts of the homework as well as these slides afterwards, so you can review them. Yes, feel free to put your questions in the chat, but I do have one question to start, which is, and I've seen there are multiple resources that say different things, but in terms of target sample sizes for user testing and heuristic evaluation, what should we aim for to have enough confidence that we have at least identified the critical incidents from our evaluations?
Okay, that's a very good question. I can answer that for both the usability inspection. Now, the usability inspection, we're not observing users, we're doing it. But if we want to be more replicatable or scientific, you might have two waivers. And then we could do inter-waiver reliability. So they call that pluralistic inspection, where you have a waiving team or maybe two working together, resolving discrepancy through discussion or that. So basically the first ones that we show, we won't have to worry about N or sample size for the subject because it's predictive. When we get to the ones next week when we're recording, that's a very interesting question. Jacob Nielsen did some studies where he wanted to see what the minimum number was for getting useful information. And I think he said something like about 8 as well as 8 people. And yeah, you can kind of get a feeling about that when we're doing this, often 8 people get you most things. And if you're in the qualitative analysis, you'll know the term saturation. The question is, when do you get saturation? And we get diminishing returns often after that. The one thing I would say, though, his number is kind of low because I would call that the minimum number for surface level usability problems. If you're looking at things like impact on workflow and that, and if you want to do statistical comparisons or publish statistically, I usually probably get more like 15 or 20 in the group. Sometimes it depends on the convenient sample. In the commercial world, they may go with as low as 5 to 10. And the reason being is epidemiologists and that may go, well, how can we do anything with so few? We're not random sampling. If we're a consulting company and we're building an interface for secretaries with word processing, as we'll see next week, part of the process is coming up with a user profile that's very specific, getting representative users. And if you do that, you can get a lot with less. On studies I've done on the basic surface level usability, I found 8 kind of low, but I start getting diminishing returns after about 15. And there's publications on what's the minimum number. But it's often quite different for the usability testing with live users than studies where you're doing questionnaire data with several hundred. But you're getting much different and in-depth data than you ever get from the questionnaire. And I will compare and contrast questionnaire type data with usability data next week. So a bit of a long answer, but that's a really good question. And again, if you're publishing, you want to err on the side of having more, a bit hard to do power calculations. And next week I'll talk about stats on usability testing. But another heads on that is looking at the literature and saying other studies in that literature were, independent Paul's range for this type of study. I added a journal called JMR Human Factors, and the ones I publish generally have more, but when we get a good study that had less than 10, I usually try to transfer it to what we call JMR formative research. It's another journal. So that actually says we can actually publish stuff that may not include a huge N. So yeah, that's a bit of a long answer on that one. Oh, procurement. Procurement, expand on it. We'll talk about this next week as well. On some of our, and we published on it, one of the papers we had, if you're interested in that, was the third from the bottom paper on that list, increasing the safety of healthcare information to improve procurement towards the framework for safe selection of healthcare systems. That paper, I'm proud to say, actually had an impact. I don't know on what system they selected, whether that was good or bad, but that paper was picked up by a group in Denmark that was selecting for the whole country system, EHR. And what we said was that current procurement processes where you might watch the shortlisted demos doesn't give you a chance to try it out. And what we argued for was if you're going to procure a system for millions or hundreds of millions of dollars, you should put in the RFP that is required to install the system at your location and then do the usability testing, could be inspection methods or testing. That paper has a whole program for doing that. And we got people, countries in Scandinavia to do that, although it was harder to get people here to do it. Okay, Beth and Candace.
We have so many questions, obviously. Thank you for me as well. That was a really great introduction. You packed in a lot of useful information in that hour. The heuristics you presented, they sound like universal measures that you could apply to any sort of health information system. But I wondered if you could touch on, are there any considerations and changes to your approach if you're going to be evaluating a platform like a website on that people are interacting with more often on a desktop versus something like an app that would be used on a cell phone? Do you need to change your approach based on the hardware at all and how people interact with that hardware generally?
No.
Well, yeah, that's a really good point because you may want to spin off. There was some good heuristics from I was reading a student paper and I didn't know they had them, but there were sets of heuristics that were done for mobile applications. And I haven't looked at them, but they probably got some different aspects than I think some of these were developed initially more for web applications. So there are published heuristic sets for mHealth, for example. And like Elizabeth showed for the safety ones, we just spun off ones, not for everyone, but for again, could even be used in procurement of medication systems.
Yeah, one of the big things right now is with the heuristics is that not many of them are evidence-based. So it's worth your while to do a little more investigating to find out how they were created and what was done as the background to it. It's an area that actually is that we're pursuing in terms of doing research and to shore that up. It's similar to if you have a questionnaire that you're using in a research study, you want to find out what the reliability and validity of that questionnaire is before you decide to use it. Same kind of thing with heuristics.
Yeah, but I just made them up. Now, Nelson, I know, it's interesting. Even when I first saw them, I thought, well, it's 10, it doesn't cover a lot. And it actually covers quite a lot, they're very generic. And I never found the paper, but I think initially it was reported, or he reported, I never saw the paper that he did factor analysis on usability problems. So how did they come up with 10 categories that were mutually exclusive but covered a lot? But again, I think even in the ones I showed, I added the thinking one and another one about prominence of information, because those for me were two that were really important. Oh yeah, Candace.
Okay, so I do have an audience question that was direct messaged to me. So I'll just read it out for you. So this person would like your opinion about criticism against publishing papers on usability testing regarding its limited utility unless it's being applied in a repeated improvement cycle process. For example, many cycles of usability need to be employed for it to truly make an impact. And this person is bringing this up because often with limited research budgets, there is a limitation on how many improvement cycles research studies can afford to do.
Excellent question. In terms of doing it iteratively, for designing systems before you release it, that's where you get the payback, because at every cycle, you have things you can fix before you release it. So it's formative evaluation. Now, we can also do it as summative, although the aggravation of there is if we find something harder to fix it, when the system is complete. So if it's summative, then we say, oh, we found out how many navigation problems, but maybe harder to go back and fix it. Now, so I have done usability testing in both the design phase, in cycles, and I'll get to the question about cost, and that's ideal because you can get impact release it. Having said that, people have asked, I bought a system, I have Epic or Cerner, I can't design it, it's already designed. And I know, for example, on the mainland, there's an implementation that's hundreds of millions of dollars. With that type of implementation, what we found is, and it's often forgotten in the literature, that a massive implementation has a lot of design decisions about what to put on screens, all that. So we've actually done studies, this was more with Mount Sinai Hospital in New York, if anyone's interested, where we looked at the process of rollout and said, even for a commercial system, more than just being summative, where you can't change it, but you find the problem, which is aggravating, you could triage problems and say, can we go back to the system implementation team? Maybe we can't change it. We can go back to the framers, relating framing the implementation, or maybe to the designers if it's a big problem. So yeah, the impact of usability will often depend on what part of the cycle we're in. In terms of research, you can publish about any of it. You can publish about how we used it in the design cycle. We can also publish about, we have a major implementation across province or country. What was the summative evaluation like from that for lessons learned for other implementations? Now, in terms of the cost, what I want to show, this is an issue. While I've worked on this private package, more the methods next week, with people will often said is low cost, high cost. The ones I showed today, Jacob Nelson called discount usability, because hey, it's cheap. One analyst can do it. And then they used to say the video stuff I'm going to talk about is expensive. What I want to prove next week is that the video work is not expensive. It can be very scientific, replicatable, without a big cost, but you need to work with the design team before the product is finished. How and when to bring it in, how many design cycles can you bring in to make sure it's also quick and doesn't slow the development process down. All those are issues that can and have been addressed in the research. But that's a very, very good question. And I think we have time for one more. I think Susie Wilkinson, in Imperial Health, we are working to incorporate heuristic evaluation and usability testing in the design phase of digital health tools, trying to move out of the research realm into how they work every day. And that's really, really important. The first one I'll show next week, where we recorded users, we did it at the very end, and then we couldn't change anything. And we really had a lot of catastrophes. And then after that, we said we only want to work with organizations that are willing to take the feedback to either change the design or improve the implementation of something that was commercial. Danica says, excellent point, Susie. As people use it, it becomes more organic and thus comes naturally. The other thing I will say is no matter what, even if it's not perfect, that you won't catch everything, by doing some of the methods, particularly the ones next week where users are brought in, it also brings in ownership and buy-in of the organization. If the system's implemented and there's a lot of usability problems, it's a lot easier for doctors and nurses to handle if they felt they were involved in the process, even the usability testing, than if it was just put on them. That comes up a lot. And then a couple more good questions. Abby mentioned Malbowski and asked about usability regulation or certification, especially around the ESR. Excellent question. Hopefully we can get back to that next week. There is regulation in the US. We've actually studied the regulation for products to be certified. Sadly to say, it's extremely weak. There's a US website where they can put that they certify the product, and all the certification was they had documentation. They did some usability testing. They may not even have tested it on clinicians, and they don't even have, there's no benchmark, and they don't even have to show, they just have to say we're fixing the problems. Certified. Then we get the product in Canada, and the vendor may say, well, you don't need our help because we're certified. So sometimes certification isn't useful if it's really weak. And we'll talk about that. This is EHR certification. They have it in the US, and it's particularly, I use the word lame. Usability certification. And we have links to that information. It's actually been studied, how deficient it is. Safety heuristics, look, Susie said, need to incorporate that more in the framework where Elizabeth presented. Francis says, can clinician involvement in human-centered design be the panacea for design and reality gap? Excellent question. I teach a course on human factors, and I do a whole section on participative design. And that sounds nice. You have someone on the team that's in the design team, that's a doctor, a nurse. That often falls apart when we get one person representing everyone, often the champion on the team. There are different approaches to participative design. Just email me. I've got some excellent articles coming out of Scandinavia. One approach is bring participants into the design team, but also conduct larger scale usability type studies. And they just help you point out where you might do the study rather than answering all the questions. Because what we've found is just bringing people on the team, human-centered design or participative design is not necessarily a panacea. Excellent, excellent question. I think we're almost 1:30.
I just have a couple of comments. If you're interested in sort of the safety usability argument for why it's important to do that type of work, there's an actual publication that's listed in the reference list by Baylis, which isn't on this page, but it actually provides the costing argument for why you would do usability testing, because it was cheaper to do the usability testing than to have one medical error being dealt with. And from a cost perspective, I think that's really great. There's also a really nice article, again, not on this page, but on another one by Lai and Dr. Kushner. That's a really nice one. It gives you the argument for doing the usability testing before you actually deploy a system and then evaluate. It's a really neat piece. I've always liked it because it proves that if you improve the usability of the system, if you're doing an intervention such as, let's say, helping people to better manage their particular health condition, that if you adjust the usability issues, then the power of your intervention with that technology increases. So versus the usability kind of interfering with it, and then it's not being very effective. So really do take a look at that one. It's a nice justification for why you need to include at least one cycle of usability testing.
Yeah, it should be on the presentation slides. We at all, if not, I can send that one, and I will talk about that next week. It was actually called near live testing, and they adopted the process at a hospital in New York. It worked so well.
Nice article. And then those of you who are kind of want to geek out a little bit, I always like the Patel and Kushner article. 2000 at the bottom of the page. It actually is a really cool article showing how the user interface design will actually change reasoning strategies by physicians. So you start to realize how important the technology is in terms of its effect on how we think and what we do.
All right. Well, that brings us close to time. Thank you, Beth, for dropping the link to the Google Drive with the slides for this week. Before the second workshop, we'll be sending over the new slides as well. Thank you so much, everyone who joined. Yes. And thank you again, Elizabeth and Andre, for taking us through this journey. And we are very much looking forward to workshop part 2.
Thank you.
All right.
See you next
Have a
week,
nice day,
everyone.
everyone.
Bye.